All right, so as I said in class, I'm going to make a quick video talking a little bit about the secant function and the cotangent function. So I want to start off right here with just a very quick review. We have our cosine and sine function in blue and green, and the important takeaway of graphing them together is that they're shifted by pi over 2. We have the secant and cosecant in orange and purple, and again, they're shifted by just pi over 2. Now the period, remember, is the amount of time it takes to do one full rotation. It can sometimes mean to return back to where it started. That's a fine enough way to think about it. We just have to be careful because some functions like sine, sine hits 0 at pi, and then it's back to 0 again at 2 pi. So you might be thinking, oh, well, that means it's a period of just pi. But no, that's because from 0 to pi, it's positive. And from pi to 2 pi, it's negative. So in fact, each of those is only half of the full cycle. So it's best to think about a period as how long it takes for it to complete a full cycle, not necessarily back to the same starting point, though that sometimes can be the case, right? I'm just saying that we have to be careful. There might be some instances in which those aren't perfect, so it's best to think of it as a full cycle. So the first thing we did was we jumped over here and we had an equation y equals 2 cosine of 3x. Now I noticed when I was going back through comparing this worksheet to the past worksheet, they used two different labels for the same thing, and I want to make sure that that's clear. So they have this omega, and the question is, what is omega? I originally thought of omega as the period, but the way that your book actually uses omega in the same way that we used b in the last in the last worksheet. So the idea is that this is the equation a cosecant of bx. This is how it would have appeared on your last one, but now it's appearing as omega x. So the only thing that matters is that you figure out what this 3 is doing, right? So I would say W equals B equals 3. Now, if you remember, the equation for figuring out your period is 2 pi over B, or as it shows up in your book, 2 pi over omega, which gives us 2 pi over 3. In this case, our A is 2, same as it was last time. And our amplitude is the absolute value of A, which is just 2. Now we grabbed our main points, 0, pi over 2, so on and so forth. We divided everything by 3, and that's how we created our asymptotes, and then we graphed it. Looks normal. The domain is all real numbers except for the asymptotes, which happen at n pi over 3, where n is anywhere from any whole negative number to any whole positive number, right? So, we have right here 0 and then pi over 3 and then 2 pi over 3. So that gives us our domain. The range, again, is positive infinity is the highest, and then it mins out in the positive side at 2. So y can only exist from 2 to infinity, or on the negative side, it maxes out at negative 2 and then mins out at negative infinity. So there's this idea that there's a space, right? We'll call this space right here between this piece and this piece where the function just doesn't exist. Excuse me, where the y, the function, how do I want to say this? Where the function can't get to these y's. Yeah, right, like that. So the function can't get to these y's. Yeah, so that's the idea. Is the function just, can't be in this block right here in between 2 and negative 2. Now, of course, it can equal negative 2 and it can equal positive 2. That's why we have these greater than or less than equal to, right? Because it can actually be both of those. It just can't be anything between them. Okay, so I already did a little bit of work here. So negative 1/2 secant of 2 pi x. Our a is 1/2. Our omega, which in this case is using the same notation from the last worksheet, is b, is 2 pi. Now to calculate the period, it's 2 pi over omega is 2 pi over 2 pi. This period is just 1. The amplitude is going to be the absolute value of our a, which is 1/2. So I already went through and calculated the new special points. So you take pi over 2 and divide it by 2 pi, you get 1/4, and so on and so forth. Now the original, if we go over here, we see the original asymptotes for the orange, which is secant, are at negative pi over 2, pi over 2, 3 pi over 2. So going down here, this means that our asymptotes are going to be at pi over 2, 3 pi over 2, which are converted into 1/4 and 3/4. And I went ahead and drew our asymptotes on the graph. Now, it's negative, which means that it is flipped. So normally in, say, this area right here, it would be positive, or opening up positively, but now it's flipped. So it's actually going to be opening downward. And similarly here, it's going to be opening up positively. And if we were to do this right here, it would open downward. And here it will open upward. And down here, it'll open downward. And so that is what the graph looks like. The domain in this case is going to be all real numbers minus, let's see, this is going to be n over 4, where n is equal to, well, it can't be equal to 1 or negative 1. It can't be equal to 3 or negative 3, so we'll do it like this, dot, 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 negative 3, negative 1, 1, 3, dot, dot, dot. The range, we have something similar in that it goes from negative infinity when it opens down, but it can equal negative 1/2, and it can equal 1/2, and it opens up to infinity. And this gives you the graph of negative 1/2 secant of 2 pi x. So we already talked a little bit about tangent. We went through what the graph of tangent looks like, the asymptotes. The asymptotes, of course, being when cosine is 0, because that makes tangent undefined. So in this case, we can ask, what's the period? So we see that it actually repeats itself between negative pi over 2 and pi over 2. So the period is just pi. Now let's think about cotangent. When is cotangent going to be undefined? Well, cotangent is equal to cosine over sine. So it's going to be undefined when sine of x is equal to 0. So when is sine of x equal to 0? Sine of x is equal to 0 here. It's equal to 0 at pi. It's equal to 0 at 2 pi. It's equal to 0 at negative pi, negative 2 pi. Now, we have to ask what direction is going to look like. So it's the opposite, or excuse me, the reciprocal of tangent. So that means when tangent is growing, cotangent needs to be shrinking. And what this ends up looking like is the following. We've got 0 points here because that is where cosine is 0. And it looks like this. There you go. So you'll notice if I make this a little bit smaller and see if we can get them both on the same page, then is growing because they're reciprocals, the other one has to shrink and vice versa. So that's where it ends up looking flipped. Now, what's the period? Well, we can see that it repeats itself between negative pi and 0, 0 and pi, and so on and so forth. So the period is just pi. So let's do some graphing. So the amplitude, or excuse me, the A in this case is 3, and the omega, which is equal to B from last period, is going to be 4. So what that means is the period is going to be 2 pi over 4 equals pi over 2. So now I'm going to take all of these special points and divide them all by 4. So this becomes 0, this becomes pi over 8, this becomes pi over 4, this becomes 3 pi over 8, and this becomes pi over 2. All right, now how about the amplitude? The amplitude is the absolute value of A, which is just 3. We already have the period is pi over 2. So let's jump up to tangent and double check where the asymptotes are. So it looks like the asymptotes are at pi over 2, 3 pi over 2, so on and so forth. So we're going to go here and say the asymptotes are pi over 2 and 3 pi over 2, which means that they're now pi over 8 and 3 pi over 8. So we're going to draw this. Here's our pi over 2, here's our 0, here's our negative pi over 2. We'll put this in the middle, call this pi over 4. Put this in the middle, call this negative pi over 4. Divide this up yet again. And this one is going to be pi over 8. It's going to be 3 pi over 8. This is going to be negative pi over 8. And then negative 3 pi over 8. All right, so now I'm going to draw my asymptotes, which are at pi over 8 and 3 pi over 8, and then negative pi over 8 and negative 3 pi over 8. And then let's go ahead and double check one more time. So it is increasing to the right and decreasing to the left. So it's going to increase to the right, decrease to the left, increase to the right, decrease to the left. You know, this should look like this. And let's double check and make sure this looks about right. Yes, it does. Okay. And our zeros, of course, happen at pi and 2 pi, which in this case is pi over 4 and 2 pi over 4. So this is what the graph of 3 tangent of 4x would look like. All right, so looks like that's it. I hope this makes sense. We can go over any questions y'all have on Wednesday, and we will begin reviewing for the test. All right, y'all have a good one.